Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching the videos of thermodynamics. In our last lecture we have studied about the heat capacity. Okay, and now we have to see another important topic, that is internal energy. Okay, actually internal energy is sometimes denoted by U. In some books you will see it is denoted by U, or sometimes you see that it is denoted by E. Both the abbreviations are right. You can use anyone. Okay. Actually, internal energy means the energy of the system. The total energy of a isolated system is called its internal energy. So actually the energy may be made up of two types of the energies, that is kinetic energy and potential energy. So we can say internal energy is equal to kinetic energy of the system plus potential energy. Actually, this kinetic energy that we see is made up of three different types of the energies, that is translational energy plus rotational energy plus vibrational energy. As you all know, when we consider a system, okay, suppose we are taking a system, this system is made up of different types of the molecules or atoms or anything that we call particles. This is made up of particles. Okay, now these particles are moving. Okay, so as a result of their movement, these will have the kinetic energies. Okay, these kinetic energies of three types. Translational energy, it means when the molecules are moving around its mass, center of mass. Okay, then this is called the translational energy. Rotational energy means when the molecule rotates around its center of axis. Suppose this is a molecule, okay, and this is moving around its center of axis, this is moving, then this is called the rotation, and due to this rotation it will have rotational energy. Similarly, this molecule can vibrate, it means its bond length can change in this manner, or it can move like this. Okay, so this is vibrating. As a result of these vibrations, this will have the vibrational energy. So in this system, the particles are having translational, rotational and vibrational energies, and these are making the kinetic energy of the system. Now see here, this kinetic energy is actually a function of temperature. This U kinetic, okay, this U kinetic is a function of the temperature. It means it is changing with the temperature. As we are increasing the temperature, the kinetic energy will increase. If we are decreasing the temperature, the kinetic energy will decrease. But this potential energy does not depend upon the temperature. So we can write U, total internal energy, is equal to U T plus U naught. It means this part that is depending on the temperature, that is function of temperature, and this part that is not a function of temperature. Okay, now one more thing that you should know, that the absolute value of the internal energy we cannot find out because the particles are moving. Okay, and this translational, rotational, vibrational energy is continuously changing, so the absolute value of internal energy cannot be found out. Okay, so we see the change in the internal energy. Change in the internal energy we are counting. Okay, actually suppose a system is changing from state A to state B, or we can call state 1 to state 2. Okay, then in this process the internal energy will change, so we can find out this change in the internal energy. And one thing you should note, that the internal energy is a state function. State function means its value depends only upon the state 1 and state 2. It does not depends upon the path from which the process is happening. It depends only upon the initial and the final state. Okay, so del U is given by U T2 plus U naught. This is the energy in the state 2 minus U T1 plus U naught. This is the internal energy in the state 1. So this U naught to U naught will cancel out. Okay. And what we are getting? U T2 minus U T1. Another important thing that you should know, that the internal energy is a extensive property. It means its value depends upon the amount. Okay, so it is called the extensive property. Its unit is joule. As it is energy, So its unit is joule. It can be measured either in joule or in kilojoule. Okay. If the internal energy is divided by the amount of the substance present in the system, then it will be called molar internal energy. This is called molar internal energy, and this is equal to U upon number of moles. Now you can see here, whenever we are dividing any property by the number of moles or by the molar mass, then it becomes the intensive property, because now this property does not depend upon the amount of the substance. So it is called the intensive property, and its unit will be joule per mole, or it can be kilojoule per mole. Now see the law of equipartition of energy. It means the energy can be divided into various parts. As we know, this temperature dependent part of the internal energy is called the kinetic energy. Actually, this is a kinetic energy. Okay, and its value depends upon the translational energy and on the rotational energy and on vibrational energy. It means the kinetic energy is the sum up of translational, rotational and vibrational energy. This is called the equipartition of energy. Okay, so suppose we have to find out the value of the U. We know that we cannot find out the absolute value of the internal energy, but we can just find out a basic level. Suppose we have given the atomicity. First of all, for this you should know about the atomicity. Suppose we have given the monoatomic molecules. Okay, we are making a chart here. If we have given the monoatomic molecules, in this case you will have to find out the translational degree of freedoms, you will have to find out the rotational degrees of freedom, and then vibrational degrees of freedom. Okay, whenever we know this, we can find out the translational energy, we can find out rotational energy, and we can find out the vibrational energy. Okay, suppose we are taking the monoatomic molecules. In monoatomic molecules, the translational degree of freedoms will be equal to 3. Okay, rotational degrees of freedom will be equal to 0, and vibrational degree of freedom will be equal to 0. Okay, now see, this translational energy is given by Ft into 1 by 2 RT. Okay, so its value comes 3 by 2 RT. Okay, similarly, this rotational energy is given by Fr into half RT. So its value comes 0, because here the rotational degrees of freedom are 0. So this value will be equal to 0. Similarly, vibrational energy is given by Fv into RT. So this value again comes 0. Okay. Now see, for the polyatomic molecules. In case of polyatomic molecules, when there are several atoms in a molecule, there may be two cases. One case is linear polyatomic molecules. In the case of linear polyatomic molecules, the translational degree of freedom will be equal to 3. Okay. Rotational degree of freedom will be equal to 2. And vibrational degrees of freedom will be equal to 3 and minus 5. That you all know. Okay. So, this translational energy will be equal to 3 by 2 RT. Rotational energy will be equal to RT. And vibrational energy will be equal to 3 and minus 5 RT. Okay. Similarly, in the case of polyatomic non-linear molecules, in this case, the translational degree of freedom will remain same 3. Okay. Rotational degree of freedom will be now 3, and vibrational degree of freedom will be equal to 3 and minus 6. So now the translational energy will be equal to same 3 by 2 RT, and rotational energy will be equal to 3 by 2 RT, and vibrational energy will be equal to 3 and minus 6 RT. This whole table is used when you want to find out the value of heat capacity. Okay, in some time in question papers you have given the atomicity. It means you have given the molecule is monoatomic, or molecule is linear polyatomic, or it is non-linear polyatomic, and then you will have to firstly find out the heat capacity, then you can do the question. Okay, so if you know this table, then you can easily find out the values of Cp and Cv. How you can find out? See here, I am giving you one example. See here, suppose we have taken an example of helium. Helium is monoatomic. Okay, so here the translational degree of freedom will be equal to 3. Okay, rotational degree of freedom will be equal to 0, and vibrational degree of freedom will be equal to 0. Okay, so now the energies, the translational energy will be equal to 3 by 2 RT, and there will be no rotational energy and no vibrational energy. Okay, so this is the total energy. Now value of U will be equal to UT plus U naught. Okay, so this will be equal to ET plus ER plus EV plus U naught. Okay, now you know that this value is equal to 3 by 2 RT. So you can put here 3 by 2 RT plus U naught. This is the value of internal energy in the case of helium. Okay, suppose you have to find out now the Cv, value of Cv. So for this, what you have to do? You know Cv is equal to del U upon del T at constant V. Okay, so just you have to do the differentiation with respect to temperature of 3 by 2 RT. So what you are getting? This value will be equal to 3 by 2 R. So this is the value of Cv. Now you want to find out the value of Cp. So Cp will be equal to Cv plus R. Okay. So this comes 3 by 2 R plus R. It means its value will be equal to 5 by 2 R. So this is the value of Cp. Now once you know the value of Cp and Cv, then you can find out the change in the internal energy. How? You see here. We know du is equal to del U upon del T at constant V dt plus del U upon del V at constant T dV. Okay, so now you can write du is equal to, this term will be equal to Cv dt plus pi dV. Okay, this is internal pressure. Now you can do integration. So you are getting delta U is equal to, this is between the state 1 and state 2. So I have put here the 1 and 2 sign. Okay, Cv dt plus here also limits 2 to 1 pi dV. If you are finding out this for the ideal gas, suppose we are taking the case of ideal gas. In more general cases, you will have given the ideal gas. Okay, so for ideal gas, we know PV is equal to nRT, right? So we know pi T, the internal pressure, is equal to 0. I am not giving you its verification here because we have done this in our previous lecture. If you have seen the video of equation of states, I have told you where that for ideal gas the internal pressure is equal to 0. So this value will be equal to 0. So we are getting del U is equal to integration of Cv dt is equal to n Cv m dt. Okay, this is the formula for the internal energy in the terms of heat capacity. If you are seeing for real gases or for the van der Waals gases, for van der Waals gases, you know the equation, so you can solve for that. What you are getting, del U is equal to integration of Cv dt plus integration of a n square upon v square dv. Okay, if you have given the condition of liquid and solid, then in that case you know dv, the change in the volume, is equal to 0. So always remember Cv or Cp both will be equal to C. Okay, so you can write del U is equal to integration of C dt or and integration of Cm data. So these are the key points that you have to remember in the case of internal energy. And this video is sufficient for the internal energy. Okay, in our next lecture we will study about the enthalpy. Okay, if you are liking my videos, please subscribe the channel, please comment me, please share the video, please like the video. Thank you.